Hi guys, so today we'll be solving this problem called map of highest peak. Let's read it. You are given an integer matrix is water of size m cross n that represents a map of land and water cells. If is water of ij equal to 0, then it's a land cell. If water ij equal to 1, then it is a water cell. You must assign each cell a height in a way that follows these rules. The height of each cell must be non-negative. If the cell is a water cell, its height must be 0. Any two adjacent cell must have an absolute height difference of at most 1. A cell is adjacent to another cell if the former is directly north, east, south, or west of the latter. That is, their sides are touching. Find an assignment of height such that the maximum height in matrix is maximized. Return an integer matrix height of size m cross n where height of ij is cell's height. If there are multiple, so you shouldn't return any of them, right? So we've been given this matrix, right? And this matrix has zeros and ones. So 0 denoting that it's a land and 1 denoting that it's a water, right? So if you see here, in the first example, uh, we have 0, 0, 1, 1, 0, 0, 0, 0, 0. So this is the matrix that has been given to us as an input. So if you see here, 1 is denoting the water cell and 0 is denoting the land, right? And we need to return array or a matrix such that we have maximized the height. So the height of a cell must follow two rules. So one is that the height must be non-negative, right? So it should always be positive. And if the cell, basically, if the cell is water, then its height must be 0. So like this one is 0. So this one is water, so its height is 0. And any two adjacent cell must have an absolute height difference of at the most 1, right? So at the most, it should be just 1. A cell is adjacent to another cell if the former is directly north, east, south, or west of the latter, right? So the difference between these two should always be at most, like at most, maximum it should be 1. It can be lesser than that. So difference is 0 here, difference is 1 here, difference is in between these two is 0, difference in these two is 1. So similarly, like if you see in the entire cell, in the entire answer, the pattern is that the difference between the cell is at most 1, and also the water cell is kept at a height of 0, right? So thinking about this, what approach we can do to solve this or to create this kind of matrix. So when I think about matrix, like when I think about land and water, so I think about like how we can maximize the height, right? So if this is water, so first I know that if it's a water, then I can just put it as 0 height, right? So everywhere where there is water, I put it as 0 height, right? So that is the idea. But where we need to put the land, so we need to think about some strategy to apply there or create a height such that it's the maximum, right? So if you see here, if we start at 0, so what is the layer? So the first layer, everything from it would be of height 1, right? Because the height difference, first of all, the height difference should always be at most 1, right? And if you see here in the second layer, we have here 2, 2, 2, 2. So if you see the distance from the water, like the first water, right? The distance from the water decides the height of the rest of the, basically rest of the matrix, rest of the land basically cells, right? So, which means that from here, right, I need to know that wherever there is like a land, I need to populate it with the distance it is from myself, right? So if I can go in four directions from here, so like this, and like this, right? I can just populate it with one or the value that the layer that it is on, basically, right? Okay. So yeah, the idea would be like, once we have this, we layer it with this, right? And similarly, we have this, we layer it with that values, like all the, like, neighboring values will be that value, right? From that index. That would be the idea, right? So first layer will be like this, right? So from here, I'll go here, I'll go here, I'll go here, I'll populate everything as one, right? The second layer would have the values which are already, if it's, not populated, like for example, this is not populated. So this is also not populated, like in the final answer, it's populated, but in reality, when we applied the algorithm, it's not populated. So at those places, I'll go next, right? So it would be something simple like 1 1 0. If I have this completely empty, so let's start from scratch. So we have here water and we have here water, right? So from here, I'll go left, I'll go diagonal, I go here, and I populate it to one, right? Everything else is -1, everything else. So similarly, I'll come here, I'll go top, right, and bottom, right? So I'll populate it with 1, the ones which are -1. So I'll just populate it with -1. Sorry, 1, right? Now, the other ones, so all these other values are pushed in the queue as well. Once we populate it, we push the index in the queue. So once we reach here, here and here, right? So here I'll go left, right. Right is already, 1, and left is already 0. And yeah, so bottom we have -1. So I'll populate with 2 because that's the second layer, right? That we went to. From here also, here we have second layer, right? So it would be something like this, that every water will propagate from here. So this forms the first layer, then this forms the second layer for it, right? So second layer is already like these guys are the creators of the second layer. So they pass on, they go through the four directions. Actually, it's not diagonal that I'm drawing, but yeah, it goes in four directions from that layer, right? Similarly here, everything which is not populated is the first layer from 0. And then from 0, whatever is populated from 0, they form the second layer, and then they propagate the values to the next, right? So in this way, we are actually applying a BFS approach, breadth first search. So we are targeting the water, going all four directions from it, and wherever we see land which is -1, I'll populate with the layer values of that, right? And keep on going ahead until I basically cover everything, right? So that is the idea. Let's get to the coding part in order to understand this a bit better, right? Let's get to the coding part. So first of all, i'll maintain I'll maintain a dx which is going to go in all four directions. Right. Let's get to the coding part first. So first of all, what I'll maintain a dx array, which will basically store the values that will be used for going in all the four directions, right? So dx, dy will have similarly 0, 0, 1, comma, yeah, actually, -1, 1, comma, -1, 0, comma, 0, right? So that will be used there for going iterating in all the four directions. And I'll have rows, it will be basically is water dot size, and it columns will be is water of 0 dot size. And I'll maintain basically this one will be for the final answer. So rows and vector int and columns and -1 on it, right? And then we'll have a queue which will have which will be basically used for pushing and doing the BFS, right? So that is the idea. So later now we'll be populating the cell heights. So we said that everything which has water will be height 0, right? So I'll just go through the rows plus plus and columns j plus plus, and if it is water x and y, right, then q dot push what I'll push in x and y, right, those values, and cell heights will have what, 0 height on it, right? So I'll always push the water so that I can start and I can do the BFS from there in the queue, and heights will always be 0, right? Now let's start the BFS, right? So in the BFS, what I'll do is I'll go through uh, cell q dot size is not equal to 0. Till that time, what I'll do, first of all, I will get the size of the queue. So cell q dot size, right? And then I'll just iterate through the size, right? And in this, first of all, what I'll do, I'll get the values from, the basically the queue, right? So whatever it is there on the top of the queue, I'll pop it out and use that. So where int. So whatever is the current cell, that water cell, whatever it is, so I'll just get it from the queue dot front, right? And then cell queue dot pop, right? That would be the idea. Now moving forward from here, I'll have d0, d is less than 4, d plus plus. So now we'll be traveling in all the 4 directions from here, right? So going forward now, what we'll do is parent comma int neighbor cell equal to basically current cell, whatever it is there, dot first plus dx of whatever direction that we are on, and then current cell dot second plus dx dy of whatever direction that we are on, right? So now, since we have, we'll be going from in the 4 directions from the water cell or the cell, whatever cell is in the queue, we'll have to first of all check that if, this neighbor cell is coming in direct in the, basically it's in the matrix, right? So if it's greater than equal to 0, and then neighbor cell dot second is greater than equal to 0, and then neighbor cell dot first is less than rows, and neighbor cell dot second is less than columns, right? And one more thing. So one more thing, right? That it should also be not visited. So neighbor cell, yeah, actually cell heights of neighbor cell dot first and neighbor cell dot second should be -1, right? If this is the case, so if this is the case, what we'll do is, first of all, we'll put the current index in the uh, cell queue, right? So whatever is the current index will be put in the cell queue, and also we'll maintain the layers, right? So layers would be maintained here. So layers will start with 1, and whatever it is right now will be put in the cell heights, right? Cell heights of neighbor cell dot first and neighbor cell dot second will be basically the layers, right? And eventually we'll do layers plus plus, and that will keep on going for the entire this uh, BFS, and in the end I'll just return cell heights, right? Whatever is the value, right? So that is the code. Let's run it, see if everything is working fine. So we have, oh yeah, ij, not xy. We have I and j here, I and j somewhere. Yeah, that works. Cool. I hope you guys understood the problem. Thank you so much.